The utility data for a project network is as given below. Crash the network to minimum project duration and determine the project cost for that duration. So we have been given the information regarding a project network. So we have various activities. So 0 to 1 is the first activity. So what this means is that this is the activity between node 0 and 1. Similarly, we have activities 1 to 2, 1 to 3, 2 to 3, 2 to 4, 3 to 4, and 4 to 5. We have also been given the normal time in weeks for these activities to be completed. So activity 01 can be completed in 1 week. Activity 1-2 can be completed in 3 weeks, and so on. Now for these activities to be completed in the normal time, we have also been given the cost. So for activity 01, the normal time is 1 week and it will cost rupees 5,000. Similarly, activity 1-2 can be completed in 3 weeks at a cost of 5,000 rupees, and so on. Now the project manager has also done some analysis and he finds that some of these activities can be crashed, or in other words, the time taken by these activities can be reduced to a certain extent. So this crash time in weeks is the shortest duration for completing these activities. So let's take the first activity 01. The normal time is 1 week and the crash time is also 1 week. So the shortest duration for completing activity 01 is 1 week. The second activity, the normal time is 3 weeks, whereas the crash time is 2 weeks. So the shortest duration for completing activity 1-2 is 2 weeks. For 1-3, the normal time is 7 weeks, while the crash time is 4 weeks. Now for crashing, of course, we have to either deploy additional resources or have people do the overtime. So it brings additional cost with it. So the cost associated with the crash time has been given to us as the crash cost. So this is the cost of completing these activities after it has been crashed, or this is the cost for performing these activities in the shortest duration possible. For example, the first activity, the normal cost is 5,000, but because the crash time is the same as the normal time, the crash cost is also the same. So crash cost is also 5,000 rupees. For activity 1-2, the crash cost is 12,000 rupees, while the normal cost is 5,000 rupees. So here we are reducing the time for activity 1-2 by 1 week, and there is an additional cost of 7,000 rupees. So similarly, we have been given the crash cost for each of these activities. Now you may think that, okay, why don't we take the shortest possible duration for this project as the addition of crash times? But that is not possible because first is that there are activities which are being done in parallel to each other, and also there are activities which do not fall in the critical path, so they do not contribute to the current duration of the project. So the first step to crash the project network is to draw the network diagram and identify the critical path. Now why do we need to identify the critical path? So we need to identify the critical path because critical path is a representation of the duration of the project. So the activities on the critical path are the ones for which we need to reduce the time in order to reduce the overall project duration. So let's draw the network diagram for this project. So we have node 0 and 1. So first activity is from 0 to 1. So let's say this is 0 and this is 1, and this is the activity. Now the next is 1 2 and 1 3. So let's say this is 2 and this is 3. So let's draw the activities. So this is 1 2 and this is 1 3. Next is 2 3 and 2 4. So from 2, one activity is going to node 3 and 1 is going to 4. So let's first draw node 4. Now let's draw the activities. So 2 to 3 and 2 to 4. Now next activity is 3 to 4. So 3 to 4. The next activity is 4 5. So let's draw the node number 5, and this is the activity 4 5. Now the normal time for 0 1 is 1, 1 2 is 3, 1 3 is 7, 2 3 is 5, 2 4 is 8, 3 4 is 4, and 4 5 is 1. Now in order to identify the critical path, we have to identify all the paths going from the first node, which is node number 0, to the last node, which is node number 5, and we have to identify the duration for those paths, and the path which is the longest is the critical path. So the first path would be 0 1 2 4 5. So 0 1 2 4 5. The next path would be 0 1 2 3 4 5. So 0 1 2 3 4 5. The next path would be 0 1 3 4 5. So 0 1 3 4 and 5. Now let's find out the duration for these paths. So 0 1 2 4 5 is 1 plus 3 is 4 plus 8 is 12 plus 1 is 13. So this is 13 weeks. The next path is 0 1 2 3 4 5. So 1 plus 3 is 4 plus 5 is 9 plus 4 is 13 plus 1 is 14. So this is 14. The next is 0 1 3 4 5. So 1 plus 7 is 8 plus 4 is 12 plus 1 is 13. So from this analysis, we see that path 0 1 2 3 4 5 is the critical path because the duration is the longest, which is 14 weeks. So let's identify this path. Now also the project duration is the same as the critical path duration. So here the duration of the project is 14 weeks. and we have identified the critical activities, which is 0, 1, 1, 2, 2, 3, 3, 4 and 4, 5. So now the next step will be to identify the cost of crashing these activities per week, and then out of the critical activities we'll identify the activity which has the lowest cost of crashing, and then we'll start crashing that activity. So let's first identify the cost of crashing these activities per week. So here we have to find out the cost to expedite per week. So the formula for cost to expedite is CC, which is crash cost, minus CN, which is the normal cost, divided by TN, which is the normal time, minus the crash time, which is TC. So basically we are finding out the increase in the crash cost as compared to the normal cost. So that is found by subtracting the crash cost and normal cost, and then we have to find out per week. So we are dividing it by the difference of the time. So the time which has been achieved after crashing subtracted from the normal time. So that will give us the increment in the cost per week. So for the first activity, the crash cost is the same as the normal cost. So the cost to expedite per week is 0, or in true sense there is no crashing here at all, because the crash time is the same as the normal time. For the second activity, the cost is increasing by 7,000 rupees. So 12,000 minus 5,000 is 7,000, and the time is reducing by 1 week. So basically with this formula it becomes 7,000 divided by 1, which is 7,000. For the third activity, the cost is increasing by 6,000 rupees. 17,000 minus 11,000, which is 6,000, and the time is reducing by 3 weeks. So 6,000 divided by 3, which is 2,000. For activity 2-3, the cost is increasing by 2,000 rupees. 12,000 minus 10,000, which is 2,000, and the time is reducing by 2 weeks. So 2,000 divided by 2, which is 1,000. For 2-4, the cost is increasing by 4,000 rupees. So 12,500 minus 8,500, which is 4,000, and the time is reducing by 2 weeks. So 4,000 divided by 2, which is 2,000. For 3-4, the cost is increasing by 8,000 rupees. 16,500 minus 8,500, which is 8,000, and the time is reducing by 2 weeks. So 8,000 divided by 2, which is 4,000. For the last activity, which is 4-5, there is no crashing possible, so the cost is 0. I mean, here for these activities where crashing is not possible, you can actually put a dash here, because 0 can be a wrong indicator that the cost of expediting is 0. So basically, yeah, you would start expediting this activity because the cost is 0, but actually the cost is not 0. I mean, here it is not even possible to crash this activity, so let's put a dash here. So now earlier we had identified 3 possible paths. So let's note that down. So 0, 1, 2, 4, 5, which had a duration of 13 weeks. 0, 1, 2, 3, 4, 5, which has a duration of 14 weeks. 0, 1, 3, 4, 5, which again has a duration of 13 weeks. So currently 0, 1, 2, 3, 4, 5 is the critical path. So let's identify these activities. So 0, 1, 1, 2, 2, 3, 3, 4, and 4, 5. So now we have to try and crash one of these activities which is on the critical path. So now we have 1, 2, 3, 4, 5. 5 activities which are on the critical path. So which one should we crash first? So here we'll crash the activity which has the lowest cost to expedite per week, because overall the objective is to reduce the duration of the project at the minimal incremental cost. So that is why we want to try and crash the activity which has the lowest cost to expedite per week. So out of these 5, the first one, which is 0, 1 and 4, 5, cannot be crashed. So let's leave them. Now for 1, 2, the cost per week is 7,000 rupees. For 2, 3, the cost is 1,000 rupees. And for 3, 4, the cost is 4,000 rupees. So definitely out of the 3, activity 2, 3 has the lowest cost to expedite, which is 1,000 rupees. Now the critical path has a duration of 14 weeks, whereas the other paths have a duration of 13 weeks. So if we are crashing one of the activities on the critical path, we cannot crash it by more than 1 week, because after that the other paths also become critical. So we can crash this path by 1 week. Now let's find out if it is possible to crash this activity 2, 3 by 1 week. So the normal time is 5 weeks and the crash time is 3 weeks. So definitely it can be crashed by 2 weeks. So let's crash the activity 2, 3 by 1 week. So the first one is crash 2, 3 by 1 week. So now the additional cost will be, so per week the additional cost is 1,000 rupees. So additional cost is 1,000 rupees and this duration becomes 13 weeks. So now with this crashing, the overall project duration is 13 weeks, but now 3 paths have become critical paths because all these 3 paths have a duration of 13 weeks. So in order to further crash the project, we have to crash in such a way that all the 3 paths have a reduced duration. So now we have to identify activities on these 3 paths which can be crashed together. So the best option would be to crash an activity which is common to all the 3 paths. Now the 2 activities which are common to all the 3 paths is 0, 1 and 4, 5. So 0, 1 and 4, 5 are there for each of these paths. However, 0, 1 and 4, 5 cannot be crashed. So 0, 1 and 4, 5 are not feasible options. So now we have to identify which are the other activities or combination of activities which can be crashed. So let's do that analysis. So let's first identify what are the activities on each of these paths which can be crashed. So in the first path, 1 2 and 2 4. In the second path, 0 1 cannot be crashed. Again 1 2 2 3 3 4 can be crashed. Now keep one thing in mind, that all these activities are now critical activities because all the three paths are critical paths. And for the third one, 0 1 cannot be crashed, so 1 3 3 4 4 5 cannot be crashed. Now let's note down all the possible activities, or let's note down all the combination of the possible activities on the three paths which can be crashed. So what we'll do is, first we'll take 1 2, and the second is also common, 1 2, and then we'll take 1 3 and then 3 4 and so on. So let's do this. So first we'll take 1 2 from this path, so 1 2. Now in the second path 1 2 is there, so 1 2, if we crash, both the paths have a reduced duration, so let's keep this as 1 2. And on the third path we can take 1 3, so this is 1. Second possible combination, again we'll do 1 2 1 2 and then we'll go here, so 3 4, so 1 2 and 3 4. Third is 1 2, and then now we will go to the next possible activity on the second path, so 2 3, and the first one on the third path, so 1 3. So 1 2 2 3 and 1 3. Then next 1 2 2 3 and 3 4. So now we have completed 2 3. So now let's go to the next, which is 3 4. So 1 2 3 4 and 1 3. So 1 2 3 4 and then 1 3. Now we'll go to the next one on the last path, which is 3 4. So 1 2 3 4 and 3 4. So now in this 3 4 is common, so if we crash 3 4, both the paths will have the same amount of reduction in the duration. So we have 1 2 and 3 4. But I see that 1 2 3 4 has already been done as part of a different combination, 1 2 1 2 and 3 4. So it's the same, so we can actually cancel this one. So now let's move to 2 4. So 2 4 1 2 and 1 3. Next is 2 4 1 2 and 3 4. Next is 2 4 2 3 1 3. Next is 2 4 2 3 3 4. Next is 2 4 3 4 1 3. So let me note it down here. So 2 4 3 4 1 3, and the next is 2 4 3 4 and 3 4, which is again 2 4 and 3 4. So 2 4 3 4. So if we have to further reduce the duration of the overall project, then we have to reduce the activity duration in such a way that all the three parts have reduction in their duration. And in order to do that, we'll have to choose one of these combinations. So now let's find out of these possible combinations which has how much cost for reduction or for crashing, and then we'll take the combination which has the lowest cost. So 1 2 1 3. So 1 2 is 7,000 and 1 3 is 2,000, so this is 9,000. Next is 1 2 3 4. So 1 2 is again 7,000 and 3 4 is 4,000, so this is 11,000. Next is 1 2 2 3 and 1 3. So 1 2 is 7,000, 2 3 is 1,000, so this is 8,000, and 1 3, which is 2,000, so 8 plus 2 is 10,000. Now next is 1 2 2 3 3 4. So 1 2 is 7,000, 2 3 is 1,000, so this is 8,000, and next is 3 4, which is 4,000, so this makes 8 plus 4 12,000. Now next combination is 1 2 3 4 1 3. So 1 2 is 7,000, 3 4 is 4,000, so 7 plus 4 is 11, and 1 3 is 2,000, so 11 plus 2 is 13, so this is 13,000. Now next is 2 4 1 2 1 3. So 2 4 is 2,000, so 2,000 plus 1 2 is 7,000, so 2,000 plus 7,000 is 9,000, and next is 1 3. 1 3 is 2,000, so 9 plus 2 is 11, so this is 11,000. Next one is 2 4 1 2 3 4. So 2 4 is 2,000, 1 2 is 7,000, so 2,000 plus 7,000 is 9,000, and 3 4, which is 4,000, so 9,000 plus 4,000 is 13,000. Next is 2 4 2 3 and 1 3. So 2 4 is 2,000, 2 3 is 1,000, so this is 3,000, and 1 3, which is 2,000, so 3 plus 2 is 5,000. The next is 2 4 2 3 3 4. So 2 4 is 2,000, 2 3 is 1,000, so 2 plus 1 is 3,000, and 3 4, which is 4,000, so 3 plus 4 is 7, so this is 7,000. Now coming to these 2 4 3 4 1 3. So 2 4 is 2,000, 3 4 is 4,000, so 2 plus 4 is 6,000, and 1 3, which is 2,000, so 6 plus 2 is 8,000. Next is 2 4 3 4. So 2 4 is 2,000, and 3 4 is 4,000, so 2 plus 4 is 6, so 6,000. So this is the combinations and their cost analysis. So now let's identify the combination of activities which has the lowest cost. So the lowest cost is this number 8, which is 2 4, 2 3 and 1 3. So 2 4, which is this, 2 3 and 1 3. So 2 3 and 1 3. Now we have to crash all the three activities because we have to crash all the three paths. So 1 3 is on this path, the third path, 2 3 is on the second path, and 2 4 is on the first path. So we have to crash these three by the same duration so that all the three are crashed. So now let's find out how much can we crash this combination by. So 1 3 can be crashed by 3 weeks, 2 3 can be crashed by 2 weeks, but hold on, 2 3 we have already crashed by 1 week, so let's change this to 4. So now 2 3 can be crashed by 1 week only, and 2 4 can be crashed by 2 weeks. So the lowest is 1 week, so we'll crash all the three activities by 1 week. So second is crash this combination here, 2 4, 2 3, 1 3 by 1 week. So the additional cost is equal to this much, which is 5,000 rupees. Now these costs are the cost per week for crashing this combination. So if we were crashing this combination by 2 weeks, the cost would be 5 multiplied by 2, which is 10,000 rupees. So now let's reduce the duration of these. So first is 2 4. So 2 4 gets reduced from 8 to 7. 2 3, this reduces from 4 to 3. And 1 3, so this reduces from 7 to 6. And now these paths, they get reduced by 1 week each. So these become 12, 12 and 12. So now one thing to note is that 2 3 has reached its maximum crashing possible, which is of 3 weeks, is the shortest duration possible for this activity. So it cannot be crashed further. So all the combinations which have the activity 2 3 are now no longer valid and cannot be crashed. So let's cross off all the combinations which have activity 2 3. So this is not possible, this is not possible, this is not possible, this is not possible, and that's it. So haven't missed anything. Nope. Alright, so now let's see if further crashing is possible. So let's now take the next lowest cost for crashing. So now the next lowest is this combination here, number 11, 2 4 and 3 4, which is 6,000 rupees. So let's take this combination. So 2 4 and 3 4. So this is 2 4, which is this, and 3 4, which is this. Now let's see if crashing is possible. So 2 4, yes, from 7 to 6 is possible, 1 week, and 3 4, 4 to 2 is possible because there is a potential for reducing this time by 2 weeks. Now the minimum is 1 week, so we have to crash both the activities by 1 week. So third is crash 2 4 and 3 4 by 1 week. So the additional cost is equal to 6,000 rupees. Now here one thing to note is we are crashing 3.4, and 3.4 exists in both the second and the third path. Now we don't have to take the cost and double it up because it exists in two paths, because this is one activity. So if you reduce the time for this one activity, the duration of both these paths get reduced. So now the after this crashing 2.4 and 3.4, the duration of these paths become 11 weeks each, and 2.4 3.4. So let's reduce the duration. So 2.4 is now 6 weeks and 3.4 is now 3 weeks. So now if you know 2.4 has reached its maximum capacity to be shortened, so let's cancel out all the combinations which have the activity 2.4 because we can't further crash it. So this has 2.4, this has 2.4, this one has 2.4, and this one also has 2.4. So now there are still some possible combinations, and all these three paths are still critical paths. So let's continue our analysis. So let's find out which is the lowest cost combination. So out of these three, the first one, which is 1213, is the lowest. So let's find out if we can crash these two. So 12 is this one and 13 is this one. So 12 can be crashed by 1 week and 13 can be crashed by 2 weeks. So let's crash these two by 1 week each. So the fourth crashing is crash 12 and 13 by 1 week. So the additional cost is equal to 9,000 rupees. So now this becomes 2, this becomes 5, and these become 10, 10 and 10. So now if you note, 12 has again reached its maximum, so it's not possible to crash it further. So let's check off all the combinations which have this activity. So this is not possible, this has 12, this is not possible, it has 12, and this is also not possible because it has 12. So now none of the combinations are available for crashing the project further, and we still have these three paths as the critical paths. So this duration, which is 10, is the final duration, or is the shortest duration within which the project can be completed. So the shortest duration is 10 weeks. So let me note down here. So shortest duration of project is 10 weeks. Now we have to also find out the cost for that project for this duration. So the normal cost for the project, now we'll be performing each of these activities, so we have to add this cost to find out the normal cost. So let's add these up. So I'll start from this because these are little odd, these are all in thousands, this has 500 also, so it's easier to add these first. So 8,500 plus 8,500, so 8,000 plus 8,000 is 16,000 plus 500 plus 500, so it is 17,000. So 17,000 plus 5,000 is 22,000, 22 plus 10 is 32, 32 plus 11 is 43, 43 plus 10, because 5 plus 5 is 10, so 43 plus 10 is 53. So the total normal cost for the project is 53,000 rupees. So normal cost of project is equal to 53,000 rupees. But now due to crashing we have incurred some additional cost, so we have to add that cost to this if we want to find out what is the final cost for completing the project in 10 weeks. So the additional cost is 1,000 rupees plus 5,000 rupees plus 6,000 rupees plus 9,000 rupees. So let's add this up. So 9 plus 1 is 10, 10 plus 5 is 15, plus 6 is 21. So the shortest duration cost for the project is equal to 53,000 plus 21,000, which is equal to 74,000 rupees. So 74,000 rupees is the cost for completing this project in 10 weeks, as compared to a cost of 53,000 rupees if we were to complete this project in 14 weeks.